Good afternoon again, everyone, and welcome back to more Magical Math Monday, where we extend the magic of completing the square to situations where b is not even or where a is not 1. So let's take a look at these examples. Again, we are taking quadratics from standard form, moving them to vertex form, and sometimes we're going to run into these numbers. And also, unlike factoring, we can always do it. So here, let's take a look at this example. I have it on the board, but I want it in the video as well. Maisie gave us this number 7. That's a really useful number to work with. So here, I do the same thing that we were doing before. We want to take this number, -7. So I'm going to do this in another color. We'll use purple here. So I'm going to take -7. I'm going to divide that by 2, and I'm going to square it. And as I was saying on the board, I do that with fractions. So I get 49 over 4, 7 squared over 2 squared. But if you prefer decimals, you can absolutely use decimals here. This would be equal to -3.5 squared. And -3.5 squared is equal to positive 12.25. Check your calculator if you're not sure. It should be between 3 squared and 4 squared, right? It should be between 9 and 16. And indeed it is. It's 12.25. So let's take a look at what happens when we add this and subtract this from the equation. We're going to have y is equal to x squared minus 7x, and then I'm going to add 12.25 and subtract 12.25. And then I still have to subtract this -10. And then this here is, wow, I'm popular. I'm getting a lot of emails all of a sudden. This is my perfect square. It has this number multiplied by itself, gives me a positive 12.25, and added to itself gives me -7. So that's how I would factor this as y is equal to x minus 3.5 squared minus 12.25 minus 10, so that's minus 22.25. And this quadratic here, when I graph that in decimals, should be the same as that quadratic. Okay, let's take a look. X squared minus 7x minus 10. So let's go over to Desmos. X squared minus 7x minus 10. So here it is here. Let's check its vertex. 3.5, negative 22.25. 3.5, negative 22.25. What do we have here? 3.5. Remember, this is a sign flipper, so that's positive 3.5 for the x value of the vertex, and negative 22.25. So we got it. So when this gives you a fraction, you can convert it to a decimal here, no problem. I would prefer to work with it as a fraction, and my method is on the board there. It gives me the same thing. This is 22.25. Negative 22.25 is here. 89 over 4. Okay. Oh, is that a question or just checking your manicure? Checking manicure? Yeah, okay, checking manicure. Okay. All right, so carrying on. So, yeah, Nadia. I was wondering if you were asking a question, but then you were just like feeling your manicure or something? Okay, you washed your hands? You washed your hands, you said? Okay, that's fine. Now, in this case, if we want to find the vertex of this quadratic here, y is equal to negative 2x squared plus 16x minus 23, well, if I want to find that vertex, this a, I have to get rid of that first. So that's going to be an extra step that you're going to do first. In this case, we're factoring the a out of only the a and the b. You can feel free to leave the c alone. Leave it over there. So this is called partial factoring, and I'll show you what it looks like. So over here, something good? You can tell me later. I'm not going to do the tell the whole class if it's so funny thing. Y is equal to negative 2. Just let me check my fly for a second. Yeah, it's good. Okay, that's not that. Okay, negative 2 multiplied by x squared minus 8x. Okay, what I have done is I factored the negative 2 out of these two terms. So that gives me negative 2 times this. That would still create that, and I still have to minus 23. Okay, so I divided the a out from this b. So positive 16 divided by negative 2 gave me negative 8. So I have to flip that sign. And now I take the negative 8, I divide that by 2, and I square it. Okay, work with this b value inside here. Don't worry about that for now. Work with this b value in here. And then that's going to give me negative 4 squared is positive 16. Okay. Negative 4 squared, positive 16. So I'm going to add and subtract positive 16 in here. So it's going to look like this. Y is equal to negative 2 multiplied by x squared minus 8x. Put them both into brackets. Put them both inside that bracket. This is the most common error, is to put them one inside and one outside the bracket. No, you have to put them in the same place. Okay? X squared minus 8x plus 16 minus 16. Now close your bracket. Notice that this negative 2 now would have to multiply both of these things. Okay? It's still inside this bracket here. So I have negative 2 of those and negative 2 of those. And then minus 23. Okay? Do those both into brackets. I'm going to just show you that with another color where the Jerry Maguire number went. Here is my Jerry Maguire number here. Inside the brackets. Plus 16 minus 16. That's of course 0. So I did not change its value. I just put it in there. Now, this here is my perfect square. It's right there. This is the perfect square here. So factor that. Y equals negative 2 multiplied by x minus 4 squared. Okay? But now, when this one comes outside to meet his buddy over there and get collected, I can't forget to multiply this by that. This is the most common error, to forget to do this, is I need to multiply this by that. That's multiply by 2, by negative 2, and then it can come out. Okay? So that would give me negative 16 times negative 2. That's positive 32. That's going to become positive 32. And then I subtract the 23. So take a look. Where did he cut this positive 32? You want to be pretty clear on this idea of where that came from, why it became positive 32. Here is my perfect square. I created that by doing half of that squared was positive 16, and then I subtracted positive 16. So this is represented here, x minus 4 squared. But when this goes out to meet him, I need to remember to multiply by this a, and then bring it outside the brackets. That's why it becomes positive 32 minus 23. And that would give me, this is, y is equal to negative 2 multiplied by x minus 4 squared plus 32 minus 23. Well, that's plus 9. And then I should be able to show that this is the same as that. And I can check that. And do I expect you to check your answers in Desmos all the time?
Yes.
Maybe not all the time, but maybe sometimes, just to make sure that you're on the right track. So certainly just pop over to Desmos on your calculator, or sorry, on your cell phone, and type in one of these, negative 2x squared plus 16x minus 23. So let's do that. Negative 2x squared plus 16x minus 23. Okay, let's only look at that one. And now let's check its vertex. It's there at 4, 9. Okay, let's check and see what we had. Oops, not that one. It's this one. Okay, there, negative 4. So that's a sign flipper. It becomes positive 4. And then I have positive 9 over there. So this is the same thing. This is the same quadratic. So that's how you do it. Now, let's take a look at a more challenging example. This one here, notice that when I divide this 2 out from that 5, it's going to create a fraction. So these are going to be your more challenging examples. So let's see what it looks like. So y is equal to 2 multiplied by x squared minus, plus 5 over 2x, end brackets, plus 15. Notice I factored the 2 out of here, but I leave the c alone. I don't need to factor that out. You could, but don't, because you're just going to undo that work anyway later. Okay? So now I take a look at 5 over 2. That's my b. So I'm going to take my b over 2 squared and find out what my Jerry Maguire number is. Here's my b. It's 5 over 2. So if I do 5 over 2 divided by 2 and then square it, well, 5 over 2 divided by 2, that's like saying I have 5 halves of a pizza and I divide each half in half so that each half becomes a quarter. I now have 5 quarters of a pizza. Algebraically, it looks like this. 5 over 2 over 2, well, that's over 2 over 1. Dividing is the same as flip and multiply. So this is 5 over 2 multiplied by 1 over 2 squared. Okay, and that's equal to 5 over 4 squared. So 5 over 4 squared is equal to 25 over 16. I just multiply the top times the top, which is 5 times 5, over the bottom times the bottom. That's equal to 5 over 4 multiplied by 5 over 4. Okay? Get used to your fractions. It's easy to do that in your head once you're able to keep a number on top and keep a number on the bottom. And you just keep track of both numbers and it will work for you. You square both, it's really easy. If I take 5 over 2 and call that 2.5, and then I divide that in half, that gives me 1.25. And then I square it, square 1.25, and I have to reach for a calculator. The answer will be 25 over 16. It will be less than 2, but bigger than 1. Right? It's going to be up there like 1.75 or something. Anyway, 25 over 16. So I'm going to add 25 over 16 and subtract it inside the bracket. So this will look like this. Y is equal to 2 multiplied by x squared plus 5 over 2x. And then I'm going to just change colors for my Jerry Maguire number so that you see it nicely. This is plus 25 over 16 minus 25 over 16. And yes, you can convert to decimals, no problem, but I'm going to work in fractions because I'm not a maniac. And then I'm going to have plus 15 here. Okay, and that's still just the same. Now, this here is my perfect square. That is going to be a perfect square trinomial because this creates them. So I have two numbers that multiply to 25 over 16 and add to 5 over 2. That'll be 5 over 4 plus 5 over 4 gives me 5 over 2. And 5 over 4 times 5 over 4 is 25 over 16. Notice that my Jerry Maguire, the thing that will end up inside the bracket with the x is right there. That's b over 2. So this is y is equal to 2 multiplied by x plus 5 over 4 squared. And then this here. Now I have to remember to change colors so that you know what I'm talking about. This is, I have to multiply this one, multiply by 2 to bring it out. So that would be negative 25 over 16 times 2 is negative 25 over 8. It's negative 25 over 8. I just divide the bottom by 2 if I'm multiplying. Okay. So that will be, when I multiply this by 2, you might write that out in some scratch work here. Negative 25 over 16 times 2. Well, that's times 2 over 1. This 2 can cancel one of the 2's in 16 and make it 8. So it's negative 25 over 8. So this is going to come out as negative 25 over 8, and then I'm going to add 15 to it. Let's write 15 as some fraction over 8 plus something over 8. Well, that would be 120. How did I do that? Because I multiplied 15 by 8 in my head to get 120. 15 times 8, 120. So this is 120 over 8. Not hard. And then I add these together. Negative 25 over 8 plus 120 over 8. That's 95 over 8. 95 has no factors 2. So that's already reduced. Final answer. So this is equal to y is equal to 2 multiplied by x plus 5 over 4 squared plus 95 over 8. If I wanted to express that as a decimal, this is just 1.25, 5 over 4. And this one, 95 over 8 as a decimal. Well, how many is this? 10, 11, 11 and 7/8. So 11 and 7/8 would be 11 point, is that 875? 11.875, yeah. So this is the number 11.875. I find 95 over 8 a lot easier to understand than 11.75. to be honest. Well, no, it depends on what situation. Like if it's money, 11.75 is a lot easier to understand. It's $11.75. Wait, no, it's 75? 11.825. 825, I think. Yeah. Anyhow, so that's this topic. The trick is when A is non-1, you factor it out first. That's your first step. And then you find your Jerry Maguire number using this one, no problem. Put it inside brackets both. And remember, when you take this one outside to rejoin his other friend there to create your K value, whatever the optimum value is of the vertex, you have to multiply this by this to get this to bring it together. That's all. Use decimals if you like, use fractions if you like. I would try both methods today. Even if you don't like fractions, notice I'm really good at math and I really like fractions. I much prefer them to decimals. If you are not so great at math and you prefer decimals, probably your dislike of fractions is holding you back in your math development. So challenge yourself a little bit to do some of these problems with fractions. So the problems that you can practice here are 7, 8, and 17. And next I'll do a walkthrough video of the delta math. So you can tune in for that, or you can get working on your own. Both are available. Both are great options. Bye for now, everyone.